So basically in the break, we had some interesting discussions, and this brings us to the second part of our prologue lecture today about cloud computing and big data. So what are now the different topics and subjects we talk about? So we had a kind of motivational introduction to cloud computing, that it relates to big data, to deep learning, to different applications. And now we will walk through the different parts of the lectures and what you see as materials. I could also hint basically, again, and a reminder that essentially a very similar course from last year is already on YouTube. So if you are interested what the different lectures will be, you can browse into this. Of course, I will change them here and there. There need to be some updates. Some services are changing to some different factors, but essentially 80% of the material is already, I guess, in YouTube. However, the learning experience is, of course, when you really do the hands-on exercises, when you really learn to use the clouds, look into this, than just using the lectures. So basically in this part of the lecture, we will now move to all the different lecture pieces once again and see roughly what we want to cover there, what are the basic ideas about this. It also helps you maybe connecting things to other courses, things like databases, which is teach somewhere else and so forth. So in a way, the prologue is a very short introduction into this topic, just to get you up to speed about the organization and the relatively 10,000 feet perspective of the course. In lecture one, we will, going closer, and then we'll really do an introduction from a more perspective of basic fundamentals, what you need to know to understand cloud computing. And you see essentially there, we will talk a bit some historic elements, how cloud computing came into existence, which is based in parallel processing, distributed systems, coming over high performance computing, then to this established term, cloud computing that we have there today. And then, of course, lots of examples, right? We look into some software as a service, Salesforce service models, but also maybe on Amazon Web Service from the infrastructure as a service perspective. So bare metal, if you just want to have metal somewhere else, or virtualization, a virtual image, or so another, let's say, remote computer. Things which are all maybe don't mean anything to you, but we establish that in the basics step by step, when we then pick it up to more, let's say, advanced topics in the course in lecture 4, 5, 6, and so forth. Again, we have the practical topics always intertwined. Think about this. This is based on student feedback, so to really get hands-on early. Otherwise, we would just do the first 6 lectures, theory, 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 but then half of the semester is over, and then starting with the assignments is not really good timing, and people, are not motivated anymore. So we really inject here and there some topics. You will realize that with this machine learning coming in lecture 2 already, just to start early on some practical hands-on. So it continues basically in lecture 1 then to have some formalities clarified. What's the difference between parallel computing, distributed computing, or how reflect centralized computing and cloud computing then along these lines? They're all interesting terms, meaning very, let's say, elements which could be overlapping in parts. You would say that cloud computing is, of course, fueled by parallel computing, but in a different way than it would be done basically in high performance computing. Here, it's more parallel on a distributed computing fashion. And this is something what we all will materialize then in this first lecture in knowledge. There will be some fundamentals of technologies, but as I said, in this course, we will keep it on a moderate degree, right? It's important to know the difference between a multi-core CPU and a many-core GPU, but all the cache hierarchies and lots of different other technical elements we have in the HPC course. So here we go to some level properly for cloud computing, which is not so technical deep, basically, and having then, if you have interest, of course, take the HPC course. Then, of course, we will reflect how now this light of the computing, which we have here established, all reflects to data, right? Why is there so much big data around, big data analytics? I think you heard probably about the 7 V's, also the 3 V's, volume, velocity, variety, and this gets currently extended to n to the infinity of V's. But different programming ideas, why big data has lots of impacts. We have seen it in deep learning. It enables much more better models. But of course, it has also challenges. So if you want to transport always terabytes of data, you have to be ready for it. How you do this with cloud computing in a more smart way is something what we also will learn in lecture 1. In lecture 2, then, again, as I said, we start directly with some more practical topics. So machine learning, there will be an introduction to machine learning, but on a, again, moderate degree. So it's not statistical learning theories, lectures that I would do normally in a proper machine learning course when I would teach it. but this is something which, you lose all the students. So essentially here we basically have a moderate introduction to what machine learning is. Start with a very simple model called regression. Of course, we have to look a little bit what the ideas of machine learning are in terms of supervised learning, unsupervised learning, and we will also look a little bit on reinforcement learning just to differentiate from it. But again, it's not a complete proper machine learning course or deep learning course. There you have to go to other courses. However, they motivate brilliantly. On the one hand, the big data aspect, and on the other hand, the computing aspect. That's why machine learning and deep learning is kind of a key ingredient in the course. Of course, there are many other applications as well, and we cover some of them, like CRM systems, for instance, or ERP systems later on. But this is, of course, one interesting scene where you can also have hands-on. We will start very early on, also actually next week, this week on Thursday, already looking into Jupyter. It's a way how to use computing together with data. It's a Python, basically GUI that you can use to operate also remotely. We'll start with this approach, how you do it on your laptop, and then move to the cloud step by step, and then see that actually all of the different service providers, again, I have only Amazon and Microsoft Azure here, but Google also has the same possibility. So in the end, it's a way of using cloud computing resources. So that's the idea of the lecture 2 in terms of computing with machine learning. And also this will be already, let's say, a kind of indicator how your practicals will be. So essentially lecture 2, lecture 3 is material of your first assignment already to start early, which is usually something like a walkthrough, right? You get scripts from me and you have to remote log into the cloud and execute them and understand and write a little bit about them. Right. So also here, this course is not about large programming, right? This is also something what you do in other courses. Basically, the HPC course is a bit more on it. Like parallel programming here, we're reusing scripts that we basically provide to you in different cloud areas, and then executing them, understanding all these different bits and pieces is then the key idea. Because of course, all of them are a little bit different here and there, right? Of course, it means we execute some Python scripts, so you have to know a little bit what Python is doing. But there will be no big programming assignments saying, you have to create your own, a big deep learning model and so on and program that yourself. That's not part of this, let's say, credit course here. Good, once we have done this, we will see that underlying of some of the cloud services, a technology which is basically everywhere also. It's called Apache Spark. When you go now to any cloud, you basically always have Apache Spark there. It's based on the Hadoop system initially, but then basically was spinning off. And I will explain what basically Hadoop was in the beginning. We'll come to this in a little bit, but really enter Spark very quickly so that we can use it in the assignment, right? So the idea is to use it then with machine learning. It has a very nice machine learning library that you see. Of course, it has also some other libraries which are relevant for data processing. SQL is a structured query language for databases. Streaming is more, let's say, ad hoc live online data streams to digest and filter. That we usually will do more at the end of the course. It's not, let's say, the main use of data, but it's becoming more popular as data is growing. And graph databases we will have also later in the course. Facebook, for instance, takes advantage of lots of graph databases and have some examples there. But here's really the idea, just understanding Spark in the cloud. It's a technology specific one, but if you come out of the course like this, you really need to know what Spark is. So people in the job interview will want to know if you have, let's say, experience with Spark. Then when we had the first assignment, it's time to look back a little bit and look, into the cloud. So what is actually a data center? Where is the cloud coming from, right? It's not a rainy cloud out there, so it is generated somehow. So we look what we learned in lecture 1 from the building pieces of GPUs and CPUs and how we stick this now together in interesting data centers with second floors, with, gas protection in terms of fire protection. So lots of elements in a data center, which is of course completely different from the laptop business or from a small server perspective. We learn a little bit about economics of scale, why Facebook and Google data centers are so large, and the energy footprints, why the chilling is costing so much, right? Cooling it, and why Iceland, of course, is a favorite place to be for data centers, in Finland, Kajaani, and so forth. So it's really always something there. You see already Vern Global, as I said, this is a data center which is here located in Keflavik. I said it here to the room, but not to the online audience. The idea is, of course, to go to Vern Global and visit them. We went there in one of the course before the pandemic. And the hope is that we can do this again. Of course, it depends largely how the rules are from the pandemic, but it will be probably during the mid of the course. Also, it will be quite interesting to see. Then we look a little bit on all the different details, how to operate those. Again, you have to think about there must be a return of investment if you do these big computers. So there must be some payment models. What about if one of the half of the, let's say, cloud data center suddenly has all the energy lost? So how you deal with this, how you transport it to others, how they work together, the different data centers, what strategies they have in terms of service level agreements, on-demand access scheduling between different users. Everything is easy on a laptop because there's just one user. And even the operating system has several spots where you can have different users. But of course, Google data center or Facebook data centers or any data center has orders of scales. They have thousands of users at the same time. So this is also something where we'll learn how they actually deal with all of these elements. And there will be some different deployment models reflecting, again, data needs. You can imagine medical data to be put on Facebook or Google is very bad. People don't do this. So they start using their private clouds in their own facilities. And only for some model sharing of machine learning called federated machine learning, they would use then the public cloud, the concept we call hybrid clouds. Now I see question marks on all your different faces. These, of course, are very many different buzzwords we will do step by step in all of these lectures. But this is also something which is important to come out here in the course and to know that the different deployment options, how you can actually use cloud computing. Not everything is done in Amazon, MS Azure, or Google. Also, basically, the people combine those resources with their in-house resources to create clouds. And this is something what we learn in lecture 4. Lecture 5 then goes into, let's say, another different topic, which is a little bit like Spark, the idea of MapReduce. Someone heard from MapReduce, maybe? It's a very popular model, exactly. Also fueling some of the machine learning approaches, but not only, also lots of data document analysis processes are run by MapReduce. This is just an incredible platform with lots of applications, and many people use it in the cloud. And it has also the beauty of being scalable by design. Scalability is a word that doesn't mean anything to you perhaps in the moment, but is a key ingredient in cloud computing, right? That's why we have this kind of scaling up, scaling down, the flexible behavior. If you need some computing as a shopping guy, always doing your taxes, and suddenly you have your Christmas shopping, you see a large peak. So how you deal with this? Do you want to have your resources always, let's say, in the cellar unused until there's Christmas? So you have to think about that. There's, of course, a demand which is varying a lot in business in terms of computing need. And this is something we will talk about, and Hadoop is also scaling with this directly from the technology perspective. We'll look on some, let's say, simple applications on this, apart from Hadoop, how it works indirectly with, scheduling, with Yarn and so on, but also having, of course, some interesting application examples, also from the scientific perspective, but also, of course, from the business perspective. So when you come then to deep learning, this is, of course, a fascinating lecture in more ways than one. Firstly, there's a whole course about it. So, of course, I cannot speak in one lecture, a whole course to you and teach it, but I think we can get the key messages right for what deep learning roughly you can use. TensorFlow, we talked about it in the break. We will talk about this a little bit also about Keras and PyTorch. These are different frameworks on different levels. And they all basically operate the same way. They creating the so-called deep learning models in Python mostly, where you have this differentiation that we had also the first part, really to make a difference to machine learning. You kind of indirectly have models that are also do feature learning along the way, right? So many of my PhD students in the past, they did the top way, they did data, and then they spent hell a lot of time preparing features. So the satellite data, they would use, instead of one pixel, the surroundings, and would do algorithms to just have the surroundings of a pixel, because if you can imagine a water pixel, the surroundings might be also water. So you put the ingredients of the spatial correlations inside. But this would be all the work on the data, not machine learning. Once you finish that, then you have put it to machine learning, right? So this is fundamentally now different in deep learning. So essentially what you start there is now all this feature enabling, feature creation, or at least parts of it, are transformed into the deep learning architecture of this neural network. And we will talk about this, how this, of course, enables the models to go beyond the humans, to think much more smarter. One good example here is often the idea to see how a deep learning network learned to categorize images, where they said it was basically very quickly done. But when you analyze how they have done it, they just analyzed the folder hierarchy, which was painted on all the images. So essentially, you can see that there are very smart ways where the human would never thought about that this would be the best way to classify it. The deep learning way has found it. Of course, there's the other end of the scale. Who knows Boston Dynamics robots? Some of you. Maybe I don't recommend to look at this in YouTube if you want. So it's the future of military, perhaps, which is, of course, scary. So deep learning also enables, of course, interesting robots which are with superhuman capabilities these days. And of course, this has to be handled with care. If you think about that, you have a field with hundreds of them, then even the best Navy SEALs have probably troubles to getting there. So of course, it's a technology which is still in its infancy in a way, but has shown incredibly in the last 3 to 5 years, perhaps amazingly, how you can use computing with data to achieve something which is incredible. Also for the good side, right? The military robot is now one thing. You have seen in the video, perhaps, of course, drones that find lost homes and the blind people support. We have seen also as an example, showing then also there are very positive aspects of it. So all of this we will learn a little bit. As I said, the mathematical formulas we leave a little bit out for the deep learning course if you are more interested in that. Rather thinking about their different models for different types of data. So basically image recognitions, you will use convolutional neural networks that we will also use in one of your assignments with GPUs in the cloud. And then there's sequence data, which is much more language recognition. Language in a way is a sequence of characters. And you essentially use these recurrent neural network structures to think about a sequence, something in time, so to speak. And of course, the structure of these models is different, but all of those have, succeeded now what we had 5 years ago. Basically, by large, the image recognition is run by deep learning these days. And you have seen the Chinese lady speaking in the video. These are by far now the sequence model with LSTMs, GRUs, gated recurrent units. That actually have surpassed every process we had before in sequence analysis in normal machine learning. And all of this, to come back to the course material, is fueled by clouds. Deep learning uses GPUs extensively, otherwise it's terribly slow. You don't want to train an LSTM network or CNN network on CPUs. And I will show it to you. One part of the assignment will be that you train on CPUs and you will see very little progress. And then you have a GPU, and we will learn why that's the case, right? So we will learn what's the deal behind all of that. Lecture 7, then it will be a little bit more applied. There will be also the point where some of my PhD students come in. They will also do some lectures here from practical lectures in remote sensing, show you some good examples really with the data, how the spatial properties, and also we have talked about essentially the dimensions into the Earth, right? So essentially what comes back from the satellite is a cube. It's not just, kind of the overview of the Earth that you would see as a human, so to speak. How we can use these ideas now with deep learning will be part of this. And just as one example, then in the other examples, of course, the sequence data sets. So how we deal with languages, and we'll learn with this recurrent neural networks a bit more, which is a different structure in neural networks. Also there we keep the level, of course, to moderate degree. Again, we could have a whole course just around these 2 lectures, but that's not the idea. We will always make the connection back to clouds, autoencoders, why this is an interesting technology. It doesn't mean anything to you. We come to that, how this materializes then. And if you want, then coming out of the course, you're ready to use NLP applications, which is, for instance, in Iceland, a very big topic, but also, of course, around the world. When you are ready with deep learning and clouds, you have lots of good job opportunities. There are some advanced topics I will just briefly mention. This is transfer learning and neural architecture search. So don't care so much about this, but this is just the future, meaning that we need much, much more computing resources. One of the motivation behind this is that when we do neural architecture search, we never know which parameters are basically in the neural network right. We use optimizers, we use different neurons in the layers, we do different layers, we have different convolution operation, but nobody tells you that's the best way to do it. So we end up doing this not 10 times, 100 times, 150 times to find the best parameters. It's called hyperparameter tuning. And this needs computing again and computing again and computing again. And to do this in a smart way, there's something called neural architecture search to find essentially the idea how such a neural network look like more in a semi-automated fashion. And this really requires, again, cloud computing resources by the order of magnitudes. Then infrastructure as a service now comes back to some conceptual topics. Now you can imagine you're already in the assignment 2, so it's time at that time to really think about more conceptual topics again and some application examples in the field. You see here Amazon as one good example where I focus on the infrastructure as a service. Here it's really about what do you want if you want to have just storage, just computing, no big services, just essentially the infrastructure for your application. You will have a game or some other, let's say, application you want to program, and you just need, let's say, several building blocks in the cloud. The reason why I do Amazon in this particular part is the elasticity. It shows nicely the scaling up and scaling down, how they operate with this. They call it Elastic Compute Cloud, EC2, and they have interesting models there to automatically scale and up with an application needs. As I said, also, when you think about a shop or web shop, and suddenly there's this peak around Christmas or Easter, you have to deal with this, and it actually scales up and down up to the demand. And when you think about alone, the IAAS model has 70 cloud services. Yeah, so there's lots of variety from images in virtualization, where we'll talk about prepared for you for deep learning, up to really sophisticated, let's say, packages in different application areas. So there's lots of it, and overall then contributing to the all Amazon 300 services stack. So it's a big world, but we always pick those different pieces in these different lectures to show you the point, what is exactly in cloud computing and infrastructure as a service, the interesting thing. Coming then to the next level, you would say that's a basic level. The next level is definitively platform as a service, where you think about now having just normal storage, just normal computing would be a little bit thinking about basic things. So when I'm an app developer, as an example, I need more sophisticated elements. I need a payment model, where I just swipe the credit cards and the people will pay for it. I need some prepared Lego building blocks, I always call it in this, right? I just want to pick my different Lego bits and pieces and put it to an app together. And Google Cloud Platform provides lots of different elements to this. And we will have some applications, of course, again, that moderate that in different areas. I think then the Angry Birds is just one example where we look in, there are different others. And also there, the inherent use of infrastructure as a service remains, right? So the platform is just one level up. It just underneath uses infrastructure as a service, and we will make the connection also in the different basically building blocks when we look at the platform as a service. It's also taking away some interesting, incredible, let's say, software which is already there that you would have a hard time to re-implement. So in a way, you can think the difference to infrastructure and platform as a service is more a developer perspective on the cloud. Infrastructure means administrator for someone. Platform as a service is rather you're a developer and you need building blocks out of the cloud to create your own game, to create your own application. And there are lots of these platform factors which are already provided, which makes no sense to redevelop. Because otherwise, basically, you will spend up time for things where you really have no market share and lots of work to sustain this. Then the top level is things that you know, many of you. I think firstly, Google Docs. Who knows Google Docs? Bad question, I know. And there will be others like Zoho, and it's very famous, customer relationship management. Not so many know. But still, those are cloud services on the software as a service level. And basically all have their different way of just being a user-oriented cloud, right? So here, you really don't see anything anymore. In Google, you know it from your self-experience, you don't really care on which service somewhere. Is it now West Virginia or in Oregon where the Google Doc lies? You don't know yet. You just access Google Docs, you use it for your own purpose, and that's the point of software as a service. The same with customer relation management software. or enterprise resource planning. We will look into this. There's also a big market around that. And you know probably several other SharePoint. This is a like scheme. So all of those are basically now using the cloud, and the users basically have no idea where things are running. But indirectly, of course, they are related to platform and to the infrastructure as a service as well. So they don't disappear, and we will make some connections. As I said also earlier, of course, in a way, it's a bit a kind of artificial created boundary between them. You can see that essentially many of those services are now intertwined with each other, but let's say the basic principle of these layers still remain. So then coming basically at the end to the second part, we will dive a bit more into more advanced topics. Here's an example of cloud data mining in lecture 11, where we will go to a very specific part of applications, again, based on data, and where we do some unsupervised learning with clustering, but also some things which you maybe have heard before, using your market basket, what you shopped there, and basically then get some recommendations what you would shop also. This is called association rule mining and so on. So data mining in terms of shopping behavior would be one part, just as an example to again motivate the combination of doing basically data together. Now, not with deep learning, but with data mining with different paradigms. And there you can use then things like Hadoop or Spark with FP Growth, for instance, where you have a different model in terms of how to get basically substance out of data and why you need processing capability. So this is something which we always put then also into the light of cloud computing. So what happens if there's basically a failure along the way? So what happens if you basically need more scalability? We look on Bremen and small, Bremen and big in terms of point cloud analysis and so forth. I mean, this is all advanced topics we'll see then in this lecture 11 when we come there, but it will be really data to play with also in the assignments. And in a way, also something which you can also nicely use in your job application somewhere when you say you really use that already. Then another theme from data mining is basically packaging it all together, putting it all into a container. There's a large drive if you go now to job applications to see use Docker images. Have you heard from Docker images by chance? Okay, some Singularity images, similarly. So here you basically have a sort of virtualized environment, but it's more bolder than virtualization in the sense that you put all the data with it. You prepare the application to be shipped in a container, literally, and you can put it on Amazon, but you can maybe also put it then from Amazon directly of MS Azure or to Google afterwards. So all of this Docker environment, and in a way, the idea is like, now with the big transport ships that you see here in the harbor in Iceland, you put just a container on it and the next ship can take it and the train can take it and the kind of truck can take it. So the idea is here really have portability. You use basically everything what you need, put in the container, and you hopefully can execute it everywhere. Hopefully, because sometimes there are, of course, some niches and edges which you have to still manually tune, but it works quite well these days in the industry. And you will see that many people like now not to be dependent on cloud computing offerings. So if you compute everything on Amazon, you build all your package on it, and then suddenly want to move away because it's getting too expensive, you have a hard time to change all your business, basically away from Amazon. That's why Docker and this kind of Singularity and also Mesos and deployment schemes get more popular because they are supported by all the clouds. So essentially, when you do the Docker world right, you basically have a chance to get it also then portable on all the different platforms, which helps you to be a little bit, let's say, independent from the cloud providers. While underneath, of course, you use them still, but you have an easier chance to, let's say, move away. And also, of course, you kind of preserve the way how it all works together in a Docker container, but we will talk about it in this lecture. And Singularity is a very similar environment. Actually, they're also interoperable. You can run Docker in Singularity and so forth. But what that all means in context of virtualization, what's the difference to an image? I mean, some of you may now recognize, well, that sounds pretty much like a VM image, right? I can put there an image there. But Docker has a specific case, not including the operating system and some other nice features we will talk about. Then when we come to lecture 13, this is really now again, another branch of clouds. You will see I pick specific topics, which are different areas of where you could be exposed to cloud computing. Here it is actually the perspective that your boss comes to your office and says, you build me a cloud tomorrow. And you say, okay, I don't have the resources. And you say, well, I know there was an OpenStack. You know, basically OpenStack has all basic services you need to create your own cloud in-house. This is often required maybe for, let's say, medical companies that want to have a private cloud in-house, which is interoperable with Amazon. So you have things which deal with computing, with scalable computing power, with storage. And we see that OpenStack has around maybe 30 to 40 different services to help to build your own cloud, while still being here and there interoperable basically with the large clouds. And reasons are mostly, in my experience, the data that should be not shared with the large, Amazon, because of basically government problems or patient exposure. Also, you have the Patriot Act that we will look to it basically, and the safe harbor agreements and all of that has a history of Europeans don't want to upload their data into US cloud, while we use all the apps and our smart phones and smart watches to upload it constantly, funny enough. But we will have this debate basically also as part of this, motivating this a bit, why there's a private, a hybrid, and a public cloud scenario. And OpenStack gives the case then there to create your own. Some examples will be given, of course. We just pick a couple of applications. Of course, you can imagine with this Lego box, again, you can build many different applications. But of course, also it would be strange to re-implement it yourself, right? You would say out of a software engineering course from Matthias Burg or so, you would say, yeah, let's implement your own cloud processing immense, but it's all there, it's open source. So the idea is really just reusing that, binding that together with your business model, and you have your own cloud. That's what we will learn in lecture 13. Then lecture 14 will be looking into all the social media networks. Of course, not all of them in detail. We pick several branches of pieces. We look into Facebook and the graph traversal, how actually a like is digested. You can imagine that you see directly the like of someone else needs quite some performance. You see also that they do use different databases for different purposes, like for search of a friend or so. They use different aspects than the like button, which is more a graph structure. So we look how this actually works in the graph database world, and also how that reflects now Facebook, make examples of Twitter. All the popular social media platforms have one way or another how to deal with all the big of data, which is not homogeneous, right? This should explain it a little bit. It grows dynamically, virally. And we will come to this point that this is, of course, a hard catch for clouds to deal with this. The other facet of it is to show why it's so successful. So I give you some examples how to work with AdWords and AdSense. Someone is using that maybe for websites already to earn money? No. Okay, well, if you go to websites this day, you have always this annoying advertisements, but they mean, of course, a lot of money, right? The more visitors you have, the more clicks. I show you how to do it. AdSense is the other side around, basically, of this. AdWords is what you see there, and AdSense is how you steer them. But this will be also the part of it. And thinking also about what is the business model of Facebook, it's free. It is the ads, right? The similar thing like Google ads, they have also Facebook ads that you can buy. You can basically buy to be promoted. All of these will be topic basically of this part of the lecture, and how it, of course, is fueled by cloud computing and data. Then towards the end, really a really advanced topic. We could have a whole lecture about it. It's basically dealing with data streams, really constant data coming in, not just lying data somewhere in silos for events, for instance, and so on, where you want to maybe just pick the most important part out, because it's impossible to keep everything. You would try to filter. You would see that the picture on the top, you see to filter out the most important events for your company. You can think about a Twitter stream, and what you want to know is a sentiment analysis about my product. So you're not interested in all the Twitters that comes, but if my product is mentioned, I want to know something. What are the people talking about my product? So this is something what we will deal there, how the frameworks like Flink and also Spark actually have the streaming library, how we can use that for these purposes. They are very rich libraries. You can use them for many things, but streaming is probably also one of the future important parts. That's why I put it at the end, because also we will see that the data is so growing enormously that's really becomes a question to keep everything for companies, right? And this will be probably also more future research. You see also already Flink there. This is a new Apache product, which basically has also much more performance that we had previously in Hadoop and Spark. So you see specific frameworks dealing with these things. But this will be really more or less the end. Then we are already talking December here and ready for Christmas. So we will have one lecture, which is an informal lecture closing the course and called the Epilogue, where I have lots of job applications, which we will review and highlight with the topics of the course so that you see again the matching way would have a chance on the job market, maybe to have really a good chance, basically with all of these different topics we looked, and maybe look on different levels, more on the mindset level, what really cloud computing gives you now instead of building a big server farm, maybe in your own application, basically house, which could be either a company or a startup or academic setups. The skill set, of course, there you learn a little bit more about machine learning, which always goes nowadays often together in job applications. So it's a very hot market in machine learning. There are no experts around, right? They're all basically missing. And you find every second job application is somehow machine learning. That's why I also put it a lot in the course. It's a very attractive topic. And there are also lots of PhD and machine learning, master thesis topics around. And then at the end, tool set, of course, you learned Hadoop, the cloud services of Amazon. You're ready for the market with MS Azure, also the Google platform, you know. And basically, once you have done the course, you're ready to use any other clouds because the similarity is often very, very common, like using Jupyter maybe in a cloud for neural networks. We shed light shortly on quantum computing. My research group does a couple of first applications on this, on quantum annealers, which is quite an interesting topic, but still in its infancy. Just to give you a broader perspective of computing, that cloud computing is now the one scale which has matured, but we in research already in quantum computing, quantum annealing, which solves machine learning like this and don't need GPUs anymore, so many on scale, but it's really a new research topic and quite complicated. Right, and with this, I would just maybe finish with another short video, if you allow me, a little bit maybe over time. But I think it's still worth to look at this video.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers, so you can focus on what matters most to your business.
All right, another disclaimer that I'm also not paid by Amazon. That's all for today. You see basically a lot of bibliography, always alongside the slides. Of course, I encourage you to look at them if you like to be a bit more in all the different topics. Otherwise, I think it's all for today, and see you basically on Thursday in VR2 though. Thank you very much.